calculate the formula of a straight line. So the first thing we need to know is what standard formula looks like. So standard formula looks like y is equal to mx plus c, where m is my gradient and c is my y-intercept. Alright, so if I go have a look at a Cartesian plane, this will be my x and this will be my y. So if I give you, for example, the formula y is equal to 2x minus 4, it means my gradient is 2, so that's how steep it is, and if it's increasing or decreasing, and minus 4 is my y-intercept. So I know it's going to cut over here by -4. Alright, so if they ask you to sketch a graph, so they would give this to you, and then they ask you to sketch a graph, you've got one of two options. The first one is to use table mode. The second one is to use your dual intercept method. Die afsnitmethode vir die Afrikaanse kinders. Okay, so what we're going to do is let's quickly go do this in table mode, and then I'll show you how to do it with the dual intercept method as well. So the first thing I'm going to do with my table is I'm going to go divide it into x and y. I like to start by -2 because then I've got enough points to work with. So what's important is this, I choose myself, but I want some negative and some positive. And then all I'm going to do is I'm going to substitute it into x's place over here. So I'm going to say 2 times -2 minus 4, this is going to give me -4 is -8. Alright, so we've got that coordinate over there. Then I'm going to replace in x's place, because remember this is x and x is over there. So I'm going to put that value in there, and then I'm going to get -6 as the corresponding y value. My x value, if I could go put 0 in, then it's going to be -4. Then I'm going to go put 1 in, that's going to give me -2, and then if I put 2 in, I'm going to end up with 0. Alright, so now, remember how a Cartesian plane runs? It goes 1, 2, 3, 4, 5, and then it goes negative. -1, -2, -3, -4. Alright, so I'm going to use my y values to sort of get an idea of the kinds of points that I want. You only need to sketch 3, so I'm obviously not going to sketch those 2. I just like having it in case I end up with fractions. I don't really like sketching fractions, so then I just choose the ones that were whole numbers, but all 3 of them were whole numbers, so I'm not too concerned. Alright, so where x is equal to -1, y was equal to -6. So I would then go to -1 over here, and its corresponding point was -6. So I'm going to put my dot over there, right by -1 and by -6. Where x was 0, my y value was -4. And then when my x value was 1, my y value was -2. So that would be -3, and that would be -2. So that would make the point right about there. Alright, then I'm just going to go draw a straight line that goes through all of those points, and I'm going to put little arrows on to show that it's going to continue. Alright, so this is the table method. You can also use your calculator. So if you take your calculator, you can go to mode table. So on my calculator it's 3, and then you can go put your equation in. What's important to remember is that fx, gx, hx, all of those things mean the exact same thing. They mean y. So if they say to you, fx is equal to x minus 2, what they're actually saying is y is equal to x minus 2. Alright, it's just often when we have more than one graph, we like to use different names for them so that we don't get confused. Alright, so that was the table method. Let's go have a look at the dual intercept method, because it's a lot easier. A lot of people prefer the dual intercept method. So in order to do the dual intercept method, let's do this one again so you can see. So we will have our Cartesian plane again. Alright, so the dual intercept method works like this. If I want my x-intercept of my x-afsnit, then what I'm going to do is I'm going to make my y equal to 0. And when I want my y-intercept, my y-afsnit, then I'm going to make my x equal to 0. So I always make the opposite one equal to 0. So to get my x-intercept, I'm going to take my function and I'm going to say 0 is equal to 2x minus 4 because I want to make my y 0 and y's position is over there. I'm going to bring my 4 across and I'm going to get x equal to 2. Right. Then I'm going to make, for my y-intercept, I'm going to make x equal to 0. So I'm going to say y is equal to 2 times 0 minus 4, which means my coordinate is -4. So remember, coordinates are written as x and then y. So this one's coordinate is going to be 2 and 0, and this one is going to be 0 and -4, because it's always x and then y. So all I have to do is then just sketch these 2 points. So my first one is 2 and 0, so it would lie around there, and my next one is 0 and -4, so it would lie around there, and then I'm just going to connect it like that. Right, so a lot of people say this is a lot easier to do the dual intercept method, but sometimes they ask you to use the table mode. Right, so that is the graphing of straight lines. Let's quickly go have a look at domain and range. Definisieversameling en waardeversameling. Domain is the same as definisieversameling. And range. Dit is dieselfde as waardeversameling. And domain is always asking me, what is my x range? So what can my x values be? Anytime you see an arrow, your domain is always just going to be x is an element of real. So it's going to be all negative values and all positive values because there are arrows indicated. You can also write it as x is an element of negative infinity to positive infinity. You can also write it like that. This is just a little bit easier. Right. The same is true for the range, die waardeversameling. That has got to do with my y. So with a straight line graph, my range is also always going to be y is an element of real, or you can write it as y is an element of negative infinity up to positive infinity. This is only the case when there are arrows. There aren't always arrows. Sometimes they do the following. Right, now they give us definitive points where we need to stop. So if I have a look at my x values range from -1 to 4. So in this case, I'm going to say x is an element of real. It starts at -1 and it's a square bracket because my dot is colored in, so it's included. Where here, I'm going to make a round circle because my dot is not colored in, so therefore it would be excluded. So that's going to be my domain, my definisieversameling for a graph like this. My range is going to look like the following, because we've got -4 to 2. Once again, y is an element of real. It starts at -4 and it ends at 2. So because this dot is colored in, I have a square bracket, and because that one is round, I'm not colored in, I'm going to make it round, because it means it is excluded. Alright, so this is the foundations of graphs. Let's quickly go have a look at how to calculate what the formula of a graph is. Oftentimes they also give you things like 3y minus 2x is equal to 6. We can never work with a graph in this format. We always need to get the y alone. We have to put in what's called standard formula. And standard formula is always y is equal to mx plus c. So basically what that means is my y must always be alone. So the first thing I'm going to do is I'm going to bring this 2 across, and it's going to become a positive because it was negative there. And then I'm just going to divide the 3 away. And that is my formula in standard format. Okay, now if they give me 2 points, so let's say they give me 0 and -4, and they give me 2 and 0 as an example, and they ask me to calculate the formula of the straight line. The first thing I always want to calculate is my gradient. Now the formula for my gradient is y2 minus y1 over x2 minus x1 is going to give me my gradient. In the beginning, while you're getting used to this, I would recommend you go and label these things, because you cannot use this as x1 and that as y1. You have to be consistent with which one is going to come first in my fraction. Alright, so always remember it's x then y. So, and don't get confused. A lot of people put the x at the top. Make sure that you know that you have to start with your y's. So I'm going to start with 0 minus 4, because it's a negative and the formula requires that I minus, that is going to become a positive, over 2 minus 0, meaning my gradient is 4 over 2, so my gradient is equal to 2. Okay, now I have my gradient. Once I have my gradient, I'm going to substitute it into the formula. Y is equal to 2x plus c, right? I'm then going to pick any other coordinate that I'm going to put in x and y's place. So let's take this one. So let's make y then negative 4 is equal to 2 times 0 plus c, and then I just solve for c with a linear equation, net die doodgewone vergelyking, which means c is going to be equal to negative 4. You are only done with the formula of your line once you have it written like this, where the only variables unknown would be your y and your x. Right, so this is how we get the formula of a straight line. Now, we need to remember that when lines are parallel to each other, evenwydig or parallel, so they look like this, then it means their gradients are exactly the same. Alright, so let's say I say to you this line over here was y is equal to 2x minus 4, and I give you another coordinate over here and I say it is 6 and 8, for example. And I ask you to calculate the formula of the second line. So the problem is I only have one coordinate, so I won't be able to calculate a gradient for this one, because you need two coordinates to calculate a gradient. What I do know though is that this gradient was 2, and they're parallel to each other, which means the gradients are the same. So I don't have to go and calculate the gradient. So my formula is y is equal to 2x plus c. And now all I have to do is sub in those two numbers. To get my formula of my graph. And this is the formula of the line that is parallel to the first line we just calculated. Alright, so that's how it works when it is parallel. The gradients are always exactly the same. Now let's quickly go have a look when it is perpendicular, wanneer dit loodreg is. So when it looks like this. Okay, so you have 90 grade hierso. M1 and M2 would lie here. When I say M1 times M2, it must always give me negative 1. Alright, so let's pretend this line is that line over there, and it's still y is equal to 2x minus 4. And I ask you to calculate this one if I give you the coordinates as 6 and minus 2. And I ask you to calculate M2. Once again, you only have one coordinate on the line, which means you can't go and calculate the gradient with our gradient formula. You have to use this formula to get it. So the gradient from this line was 2. So I just have to divide that away, like a normal equation, to get my new gradient as negative a half. So y is equal to negative a half x plus c. Now I can just go and sub my coordinates in. So my formula is y is equal to negative a half x plus 1. And there's the formula of my perpendicular line. I hope this lesson helped. If you have any questions, you're welcome to contact me, and I can clarify anything that might not have been clear to you.